Hi and welcome to my tutorial once again. This tutorial focuses on product laws and sum laws with their equivalent switching circuits. So to understand this further, let me take you back to physics on the types of circuits that we have. We have series circuits and parallel circuits. We shall look at them one after the other. So let's start with series circuits. So a series circuit is one that has more than one resistor, but only one path through which the electricity or electrons flows. And if you look at the series circuit, think of an AND gate, because an AND gate is an equivalent series circuit. So here is an image representation of a series circuit. So as you can see from the definition, to say it only has one path through which electricity flows. Let's say, as you can see here, we have switch A and we have switch B, and this is the lamp that we're supposed to light. So there's only one path here really which these electrons will have to flow through and reach the bulb to light it. But then if these two switches are open, it means power won't pass through, hence the lamp won't go on. So it's a series and it only has one path. Okay, so taking you to the laws now, you should have that logic in mind of a series circuit, to say whatever happens, as long as one of these switches is open, electricity won't pass through. If they are both open, it's even worse, unless if both of them are what? Closed. That's when power can go through, because it depends on one path. Then this is one of the product laws, A and 0. So the equivalent switch A in series with an open switch. So this is a series circuit, and then this switch here is already open. So this 0 here represents this switch here and it's open, and then we have an A here. So in this case, we are going to think of all possible outcomes, whether the value of A is 1 or the value of A is 0. As long as the switch here is open, the bulb won't go on, so it will be off. And if it will be off, that's why we're having the results as 0, because if you remember, I said 0 stands for off, logic off. 1, it will be on. Okay, so that's what we're representing. We're using to represent the output, and then A here is just a variable representing the conditions. Okay, that is the first product law. Then the second law here is A dot 1. So 1 here, that's why the circuit is closed. When it's 0, the circuit will be open, but then since it's 1, the circuit is closed. What will be the results? The results will be A, identity law. It takes in any variable that is ANDed with a 1. It takes in the identity of that variable. So even here, whatever value of A may be here, if the switch will be closed, it means the results are that the bulb will go on. If the switch is open, the bulb will go off. So the circuit conditions will depend on the position of the switch. If A is 1, the circuit is on, and when A is 0, the circuit will be off. And then we have the other one here, A dot A is equal to A. It's called idempotency. This is in the sense that all the values here, if A is 1, since this one is also A, to also be 1, and the result will also be 1, because this switch will be closed and this one will be closed, and the bulb will go on, which is logic 1. If A is 0, meaning even this A will be 0, and of course the bulb won't go on, it will just go off. So that's what this is. And then moving on to the other law, which is A dot not A is equal to 0. So we have the first switch here being A, and this one is not A. So whatever A is, the second switch is not. So if A is 1, the second switch will be 0. If A is 0, the second switch will be what? 1. It's just the opposite of each other. Okay, and as a result, the answer is going to be 0, because if this switch is closed, the other one is open, power will not go through. Even if this is the one which was closed, this one was on, power will still not go through, because the conditions of a series is that it has one path, and for the bulb to go on, we need all the switches to be closed for power to pass through. Just like here, when A is 0, yeah, then A complement is 1. It's just the opposite of each other. So that's it about the equivalent circuit or product laws. So if you had all asked to come up with the circuit and the law, you can still make the circuit, because this is how we're doing the combination. The important thing to note and to keep in mind is that with product laws, when you're dealing with AND gates, just think of a series circuit, just like in physics, where a series circuit is one that has more than one resistor, but only one path through which the electricity or electrons flows. So you can have more bulbs, it can light up as many lamps as possible, but the path is only one. And if one switch is on, even if the other switches were, if one switch is open, even if all the other switches were closed, electricity will still not go through. Condition is that all the switches should be closed for power to go through that same one path and reach the lamp. And it is the same logic and gates that we are using for product laws to come up with these circuits. Yep, so I hope you've understood. So the next tutorial, I'm just going to look at the sum laws and of course their equivalent switching circuits.